Right, so I'm Dr. Marc Holmes, and this is
Dr. Immersion.
And we're talking today about virtual reality as a teaching aid for anatomy. So we've been aiming to try and bring in new innovative learning and teaching techniques inside engineering, and one of these technologies is virtual reality, and we found lots of benefits coming through with the new HTC Vive as it was coming into existence. We found that there was benefit for VR learning when it has game-based. There was meta-studies which said game-based learning has a significant impact, so we wanted to try this in this trial. And by integrating 3D models, we could do identification of parts, we could walk through and have teaching interventions. The students have, increasing numbers, I think. How many is in your year group now? Is it 200? Is it?
Yeah, it's going to be up to 200.
So 200 at the moment. Some other groups are up to 500 or 600 already. So we have a limited amount of time, and we want to try and find better ways of making our teaching interventions more, have a better delta of learning. So, why anatomy? So anatomy, understanding of 3D objects. Internal research showed a benefit when using 3D TVs on stereo imaging. Sorry, let's get that back to using 3D TVs. And external research showed older cave systems showed a benefit for assembling in VR, assembling anatomy. It's a subject which sports science and medical students have difficulty with, especially we found the medical students because they weren't getting the additional anatomy training from secondary courses, so we would hope that we could help them build an understanding. So the overall aim was to investigate whether the virtual reality platform actually enhanced a students' understanding of anatomy. So the objectives were to assemble a human skeleton in VR, investigate the qualitative learning gain associated with the VR platform, gain understanding of how VR platform is regarded by the students, and investigate whether the performance in the VR platform correlates with overall achievement in the actual exam later on in the year. So we built this using Unity 3D, we used the Steam VR plugin, and we used VRTK, which has a lot of scripts in this for handling objects, snapping objects together, and making it work with a variety of virtual reality kits, not just Steam VR, but Oculus and all the others, so that takes out all the hard work of writing all these things. So we needed to look for a source of material. Originally, we wanted to do a thing called photogrammetry and scan bones, but we found out that would take a year just to get a basic set and more to get the full detail which we were talking about. What we did find, though, was this database, the Japanese life science database, which has a variety of scans from CT data, and they're all OBJs ready to use, and they're all Creative Commons, so you can download them and use them. So they use this quite heavily for printing 3D parts of the body, so you guys to handing out in the medical school. So we use this as our database to have the body parts from. We use VRTK as the base, so we use the snapping zone and we use the radial UI. So snapping zones, you drop bits together. There's a very basic human skeleton where you assemble, and then you've got radial choice for like the multiple choice questions for answering. So we had to work on a lot of different changes. You can see that those changes go on my GitHub, which I think is in reference in this document. But basically, you assemble a skeleton, drop it in place, and you answer questions. So I do recommend giving that a go at the end of this. The headset we're using is there, is the HTC Vive. We started off with a small number because we were very worried about how long this would take. So when I originally suggested this, we talked about a full skeleton build, which was 200 bones. Realistically, even if a student could perfectly identify and build all the bones in time, they'd be there for an hour or two. And that's assuming they knew where all the bones were meant to go. So we broke it down, and we focused on a smaller group of students just to do some testing to see where we go. We tried to get a group of 43 of them to come. Unfortunately, we only managed to convince 9 of them to come because it's a cold, wet Wednesday. But the ones which did come, we've got to show the dates. I think this is your section now, isn't it? Yeah, so I'll hand it to you.
Sorry, one microphone's a little bit limiting. So we wanted to really try and show that, look and see whether we were seeing a real improvement in learning gain. So it's important to try and set this up as a real research study. So what we did is we looked at a crossover to repeated measures design within the actual VR exposure. So the students carried out a quick quiz around the skeletal system, and then they either went into the VR or they sat and looked at the core textbook for the module. They redid the test, they swapped over. So we could look at sort of gain, hopefully, as associated with that. So we had two kind of things that we were really looking at. The multiple choice quiz, so the quantitative changes. And then we also wanted to know about the qualitative, so what did the students actually think about the process. Initially, really, what could we improve, what could we change over time, so that, going forward with this as a sort of bigger project, what would they want to see next were the type of questions that we asked them. So we looked at that on a very short-term basis, pre and post exposure to the VR, but also importantly for me as the lecturer on the module, I wanted to know longer term, is this actually going to change their performance on this module? So are they going to perform better on the final exam, essentially? So we also looked at that as an outcome. So the two different sides to it. So the short-term exposure to the VR. So on average, they spent around about 20 minutes actually in the VR. This was not time limited at all. It was just how long it took them to assemble the skeleton. There was a fair bit of variation in that, so you can see obviously plus or minus about 11 minutes. And you can see, looking at that figure, that shows the two different groups. So whether they did the VR as their trial 1 or VR as trial 2, and the pre, the mid, and the post. So you can see from those changes really that even if they studied with the textbook as their first exposure and then went into VR, they still had an improvement within the VR exposure, and vice versa. So it didn't matter on what order that they actually were exposed to the VR. The VR worked better than reading a textbook. So part of that might be because it was very targeted. So the only thing in the VR was the skeleton. The textbook was a human anatomy textbook, so they might have been reading about something totally different. However, they all sat the pre-MCQ, which was about the skeletal system, so hopefully they would have realized that that was what they should have read within the book. So as a group, there were significant improvements in the test score just from that 20-minute exposure to the VR experience. And importantly, none of them had ever used VR before. We didn't do some of the stuff that was really nicely discussed this morning about helping to get rid of novelty. We didn't do that. They came in, the first time they'd ever used it, and this is what they were asked to do. So that could be a factor, but the fact that none of them had ever, at least it was a controlled factor. So in terms of the longer-term data, very, very happily for me, those that did the VR performed significantly better on the exam. For those of you that actually do teach within higher education, this is probably not a surprise because the students volunteered to show up. So, surprise, surprise, the best students came to take part in the VR and the best students scored best on the exam. So that doesn't necessarily tell us very much, but importantly, it wasn't just the better students. It was the better students, so they did overall perform better on all the other modules they sat in that semester. So they were the better students that came, but they still performed on average better on that module than they did compared to their other modules. So the reason that we chose particularly the medical engineers to be part of the virtual reality testing as opposed to the sport and exercise scientists is because medical engineers tend, this is first year, first semester module, so the medical engineers tend not to sit biology A-levels, they tend to do more sort of maths, physics, and to come into engineering. So they're at a disadvantage to an extent in this module. They historically have performed worse than sport and exercise scientists sitting in this very room listening to the same stuff. They perform worse. So that's why we chose them. So those that didn't do the VR still performed worse in this module by about 5%. Those that did come along and do the VR, you can see that they did perform better than the other group, but their performance was consistent then with their other modules. So it is sort of demonstrating a degree of learning gain across their area. So what they actually thought of it. So qualitatively, 100% of them, this is really important for us as a group going forward, 100% of them absolutely VR belongs in a higher education setting. So they all thought that that was the case. 83% of them said the main benefit was that it gave a clearer visual perception of the bones. So that's pretty important. Although, you know, I can hand around plastic bones within a lecture theatre, it's not the same as assembling them together and seeing how they sort of interact and where those interactions are. 16% said it highlighted areas they were unsure of. And this is something that definitely came through from the conversations we both had with the students, was that it gave them a little bit of a kick up the arse. So they did this and they stood in the VR and they thought, I haven't got a clue, there's a pile of bones here, I don't know what any of them are, and it was guesswork. There's one person in particular, Marc will probably talk about. Go on, have a that.
So it was difficult for me because Laura stepped out and wasn't going to be in the room because she wasn't going to interfere with her experiment. I was there and I was trying desperately hard not to tell people what they're meant to be doing. And because it's the way the game works, you've got the bones and you can try and snap them in position, and it's got multiple choice and you can eventually get the right answer. You don't get a great time, but you just get through it eventually. The problem was we came across one person who had no concept of that sort of method finding. They didn't know, they haven't played that sort of video game, or they haven't come across that sort of solution finding. They didn't just try and work their way through the answers. So it was kind of interesting to see them there, and they were struggling because I think they were one of the students who was more used to a fear of failure. They felt like every time they put a bone in the wrong place that there was something terrible which was going to happen to them because of it, rather than just put them together, and if they fit, they fit. If they don't fit, they don't fit. So it was interesting. So only thing we did with her was she was the longest one. She was there for 30 minutes. We just in the end just told her just to try pushing bones together. We felt that teaching her that wasn't going to mess with our experiment too much, to tell her that she should just try and just see what happens rather than to worry about it. She did get most of the way through. I think she got towards the hands, but I think she did say that was one of the things she realised she needed to actually start studying what she was doing. And there were some others who said they turned up and they said, I actually haven't practiced any of this, I haven't read anything since the lecture. And they said, oh, well, I actually need to get on this and learn it. So we think that did actually work as a thing to try and help them get onto it. So we're hoping next year is going to be very good on this. I just wanted to reiterate something I was going to say on the other side, is we feel that the percentage which affects the overall grade is hard to measure because we're only benefiting about, 10 marks or 5 marks? So 5 marks out of a 100-mark question. So we're only benefiting a small number of marks out of the actual total because of the limited bone set we just decided to focus on. So we're hoping next year, once we expand, we'll be targeting a larger number, so we should see a bigger benefit.
So that's the sort of 16%, so that it sort of highlighted, as we said, what they didn't really know. And then importantly, 71% of them thought that using the app helped their attainment on the module overall. So some of the free text comments then, so some of the clear benefits kind of came through within the percentages as well. So they really liked it, essentially. They're all really, really pleased with the experience. And as Marc said, what they want is basically more. So, you give them the skeleton, which is only, as I said, a small part of the module. So they want to know, right, where's the muscles? Where are all our organ systems? So they want to see incredibly fast development of this application across the rest of the module content for anatomy. So that's Marc's current challenge. So other comments, so they're really, happy that their course was chosen and that they were, able to participate in this, but would like to have extra systems in place. So key conclusions, so measurable learning gains, so both in the really short term over the one exposure, but also on longer term module outcomes. So they performed better in the exam if they chose to expose to the VR, and they liked it and they wanted to see more. So the key thing really going forward for us is this year, so starting next month, the VR side of the module will become an assessed element. So we'll get much more people having to participate. Obviously that takes out some of the benefits of them volunteering to do so, but it enables us to look at more broadly across the spectrum of students that are on the module and the effect that it may have on their learning. references, questions.
We use a similar thing in College of Human and Health Science. We use a commercially available anatomy and physiology package called Organon. I'm just wondering why you guys have chosen to go down using your own sort of bespoke software rather than using commercially available.
So first, Oregon wasn't actually released when we actually started this project. So standard problem in computer development, paper tigers, there's always a new thing coming out, which will beat your project and something really good. When we downloaded it, and we were kind of disappointed for what we want to do, because we think the same problem with the book comparison, which is probably enabling me to do another test again to do blended learning versus VR, just to prove the point, is Oregon is just disfocused. I mean, it's great. You've got every single last bit of a bone explained and pointed and explained how you name every single section of it. But that's not the point of what we need to know. They need to know for this, for the sports scientists and the medical scientists. We're not requiring that they be able to name every bone part. So that's why we decided it was not really suitable. I mean, the Body VR has a similar thing in the back, but yet again, it's just not focused on what we want to do. One of the complaints I'm getting from the students, which is being changed this year, is there was 30 in the final app. There were 36 body parts to attach, 36 sets of bones, and they said that was overwhelming. So what we're going to change it down is into sections. So they just do like the axial skeleton first, and then they do like an arm, and then they have a final version which is everything thrown at them. And Oregon just doesn't let us do that. Also, how much are you paying for it? Because it's quite a bit, isn't it? Yeah. Hmm?
To see the whole thing, you can't have it in pure just separate sections.
Yeah. Well, we found when we looked at it, we didn't think it was suitable for our purposes. We can control it. We can bring more stuff in. So, for example, we looked at in future versions, we're talking about digital diseases, which is a database of scanned photo scans and CAT scans of various body parts. We can bring in and modify it like however we want to. We're not limited to what Oregon wants us to teach.
I'm just thinking, you said that it kind of gave them a bit of a push in the right direction.
Better phrase, yeah.
I'm just thinking whether it sort of, although the exam was only focused on the content that was linked to this, I'm just wondering whether it kind of affected their overall engagement with the module, and whether looking at things like how much more they engaged with, the LE materials on Blackboard, how much they attended, that kind of thing, because it sort of, it gives it a different flavour, doesn't it?
So,
I guess we could look at that.
Just repeat the question. So because I'm meant to repeat the question for the VR people, if anyone knows. So you're asking whether it boosted their engagement with the module as a whole.
Yeah.
Unfortunately, it wasn't something we actually measured. I don't know if you have the ability to measure it in post.
I mean, I would say that the students that were the better engaged students were the ones that came. So I'd be surprised if it changed their engagement. But perhaps going forward, perhaps it would draw up the engagement of those that perhaps weren't so engaged, that it might have the same kind of potential effect for those that are a little bit more disengaged with the content, and it might do that for them, perhaps.
I was going to ask a question along similar lines, because I would imagine that because one-off intervention is very rare to find a learning game. I don't know how tailored your exam was to that particular thing that they were doing in VR. So it's quite unusual. There was, I mean, and you found a statistical result, a small number of people, but and that's quite unusual. So I would have thought it was I would have thought it would also be about that engagement, sort of motivated them to do other things beyond that then improve their exam. Not that just that. I'd be surprised if it was just that one VR experience of 20 minutes. Is it a 10-week course?
Yes.
Yeah. So that surprised me. So I was sitting here thinking the same. I was thinking it must be something about that has motivated them, or something to do other things as well.
In terms of the targeted response, the questions that were on the short term, so the pre, mid, post VR, were only skeletal system questions. So that was very targeted. Exam-wise, not so much. It's an anatomy module, so it's obviously a big part of it, but it's not the sole context. So
I feel that students did say, as we said in the feedback, they did say, as I said, some of them said they needed to get on and learn it. So it is entirely possible that the engagement, the engagement effect of the midterm test in this regards may have, changed their opinion. But what was interesting was they didn't seem to feel that about the blended learning, so the online test they were doing, because they did the online test 3 times, but they didn't seem that worried about it. But when they actually got into the VR and they actually had to assemble the skeleton, then they got worried about it. So I'm not sure why, if it's just a novelty effect, or it's the actual seeing an actual physical skeleton where they're actually getting the feedback very quickly. So it's something we can look at. We can put on, for next year, we can put on a tracking on Blackboard with their permission to see how they engage after the module. There might be a change in activity behaviour. I'm not sure how better to measure that beyond just looking at online clicks. If you guys have some better methods, feel free to mention them.
Chris, did the bespoke program yourself? How much money was devoted?
So
How qualified you need to be to do that?
I do actually intend to run a training course for everyone next year on how to do that. I've probably wasted a lot more time on it because I did it twice, because I built it for... So one of the things you have to learn about Unity, which we didn't know at the beginning, is Unity has constant upgrades of versions, and you're not meant to move upgrade versions. You're meant to stick with one version and then stick with that and ignore all the security updates and stuff. Well, you can get the security updates, but you must ignore the major version changes. So I made the mistake of upgrading and breaking everything. By the time I fixed that, it took quite a while. I think I can teach someone within a day how to build like a small section of skeletons put together. I think there's some improvements which can be made to the SDK, so the way it's actually built, so that it's simpler, because there's a couple of steps which are a bit repetitive, and I think they can be simplified down just to one step in a script. So that should, in theory, be able to reduce the amount of work someone does. But it is, unfortunately, a lot more time-consuming than chalk and talk or teach, which is always the problem with any of these VR blended learning techniques. You're preloading the information and time-consuming. But the way it is with this app, we can just keep using it again and again. The students can keep using it. There'll be VR space readily available, so once they finish their lessons or before they run up, they can have it. They can do it again, so they'll be able to get more benefit.
Any reason why you went for the Vive rather over the Rift?
So at the time, yet again, so the question is why I went for the Vive and the Rift. At the time, the touch controllers weren't out. We started this project before the touch controllers were released beyond the developer. We had 10 Vives, so that's why I went with the Vives. If you want to ask a question about so I just want to actually just expand on that one. So if you're going to ask what would you get today, well, I wouldn't get a Vive, I wouldn't get an Oculus. I would get a mixed reality headset, because I know I can't just link my display to this screen for some reason, but I actually have this running here within 2 minutes. The time and setup it would take me to set up a Vive or an Oculus is about 15 minutes, assuming everything is going right. And that's assuming I've got the cables and plugs in the right spot, whereas this one's far easier to set up. And while it has a little inaccuracy issues, generally the speed and setup is so much faster.